Welcome to Keentel Engineering. NERC Project 2022-02 just updated 3 standards at once: MOD-032-2, TOP-003-8, and IRO-010-6, built to capture how the grid actually behaves now that inverter-based resources and distributed energy resources are everywhere. Driven by FERC Order 901, this rewrites what utilities have to know about every DER and IBR on their system. Here's what changed, who owns the data, and how Keentel leads compliance. Project 2022-02 touches 3 standards together. MOD-032-2 covers data for power system modeling and analysis. TOP-003-8 covers transmission operations data requirements, and IRO-010-6 covers reliability coordinator data collection. All 3 are built for the same goal: accurate modeling, improved reliability, and FERC Order 901 compliance. So, what actually changed? DER data is now required. Location, real power capability, and resource type, whether solar, battery, or diesel. DERs are no longer treated as invisible load offsets. NERC also introduced a standard definition. A DER is a generator or energy storage resource connected to the distribution system, capable of delivering real power in parallel with the bulk power system. That definition matters because it eliminates ambiguity, aligns modeling assumptions across utilities, explicitly excludes demand response, and explicitly includes behind-the-meter resources. FERC Order 901 also mandates accurate modeling of IBR dynamic behavior across 5 parameters: momentary cessation, tripping behavior, ride-through capability, frequency response, and voltage control. This isn't theoretical. Without accurate modeling, these gaps have already caused real frequency instability, unexpected generation loss, and system oscillations in the field. DERs used to be ignored or approximated. That's no longer acceptable. MOD-032-2 now introduces aggregate DER modeling, dynamic behavior requirements, and explicit inclusion in transmission planning models. DERs are now modeled on ride-through behavior, voltage response, frequency droop characteristics, and their interaction with under-frequency and under-voltage load shedding. What about data gaps, especially for behind-the-meter solar, small-scale storage, and unregistered IBRs? The process is now 3 steps: provide actual data where it's available, estimate it where it isn't, and document the methodology, assumptions, and limitations behind that estimate. Example methods include satellite-based solar estimation, regional penetration assumptions, and average DER profiles by feeder. Who owns the data? Distribution providers collect DER data. Transmission owners step in when no distribution provider exists, and planning coordinators define the requirements. On the planning and operations side, MOD-032 feeds planning models, while TOP-003 and IRO-010 feed operational models with coordinated data sharing across entities. One important clarification: DERs aren't becoming bulk electric system assets, but their data still has to be included in reliability studies. Here's how Keentel supports this. MOD-032 compliance and data framework development, including data request templates and entity responsibility mapping. IBR and DER modeling in PSSE, TSAT, and PSCAD, including user-defined model validation and dynamic tuning. DER aggregation and estimation studies, including hosting capacity analysis and satellite estimation. Model validation and verification aligned to MOD-026 and MOD-027, comparing field data against model behavior. And grid code and FERC Order 901 compliance, including gap analysis and audit support. Keentel brings 30-plus years of experience across NERC, ERCOT, CAISO, PJM, and SPP using PSSE, PSCAD, and Power Factory. What is MOD-032-2, a NERC standard defining data requirements for power system modeling and analysis? Why was it updated? To include IBRs and DERs and comply with FERC Order 901. What is a DER under NERC? A distribution-connected generator or storage resource capable of supplying real power. Are DERs considered bulk electric system assets? No, but their data must be included in modeling. What is aggregate DER modeling? Combining multiple DERs into a single equivalent representation for studies. Why is DER modeling important? It impacts system stability, voltage, and frequency response. What if DER data is unavailable? Entities must estimate it and document their assumptions. What is IBR modeling? Modeling inverter-based resources like solar, wind, and battery storage. What parameters are required for IBRs? Ride-through, tripping, voltage control, and frequency response. What is momentary cessation? A temporary shutdown of IBR output during disturbances. Who is responsible for DER data? Typically, distribution providers or transmission owners. What is FERC Order 901? A directive requiring improved IBR modeling and data transparency. What is a user-defined model? A custom model representing specific equipment behavior. Are generic models still allowed? Yes, but accuracy and usability must be ensured. What is the unacceptable models list? A NERC-maintained list of models that shouldn't be used unless justified. How are DERs estimated? Using statistical, regional, or satellite-based methods. What is under frequency and under voltage load shedding interaction? DER response during load shedding events. What is planning versus operational alignment? Ensuring consistency between long-term studies and real-time operations. Can DERs impact transmission studies? Yes, significantly, especially at high penetration levels. What is frequency droop control? DER response to frequency deviations. What is voltage control in DERs? Reactive power support that affects grid voltage. What is behind-the-meter DER? Generation or storage located on the customer side of the meter. Why exclude demand response from DER? Because it behaves as load, not generation. How can Keentel help with compliance? Through modeling, data frameworks, studies, and audit support. Rooftop solar, behind-the-meter batteries, distributed generation. For years, the grid treated them as invisible load offsets. Under NERC's updated MOD-032-2 and FERC Order 901, that's no longer acceptable. Distribution providers and transmission owners must now model DER location, capacity, and dynamic behavior, even estimating data when it isn't available with full documentation. Inverter-based resources face the same scrutiny. Ride-through, tripping behavior, frequency response, all required. At Keentel Engineering, we turn this compliance complexity into accurate, validated models. Visit keentelengineering.com